Imagine a machine launched nearly half a century ago, before the internet, before smartphones, before modern computers. That machine is still alive. Right now, it is traveling through complete darkness, far beyond the planets, far beyond the sun's influence, into a region no human-made object was ever meant to reach. And when NASA finally understood what this machine had encountered, scientists quietly admitted something surprising. They did not expect this, because Voyager did not simply leave the solar system. It crossed a boundary where our sun meets the rest of the galaxy. This is not just a story about a spacecraft. This is the story of humanity's farthest journey, and the loneliest one ever taken. In the 1970s, space exploration was uncertain and risky. Technology was limited. Computers were slower than today's simplest devices. Yet NASA saw an opportunity that would never return in a human lifetime. A rare planetary alignment was approaching, a cosmic coincidence that happens once every 176 years. This alignment made it possible for a spacecraft to visit multiple outer planets using gravity alone. NASA called the mission Voyager. Two spacecraft were built, Voyager 1 and Voyager 2. Their mission was never meant to be eternal. Study Jupiter, study Saturn, send back data, and then fade into silence. No one imagined they would still be speaking decades later. Voyager 1 launched on September 5, 1977. As it moved through space, it carried instruments designed to measure magnetic fields, radiation, plasma, and cosmic particles. When it reached Jupiter, Voyager revealed a violent world. Massive storms, powerful radiation belts, a planet far more extreme than scientists had predicted. Then came Saturn. Voyager sent back images of its rings with breathtaking clarity. It revealed complex moons and unexpected structures. At that moment, NASA faced a decision that would change history. They could redirect Voyager toward Pluto, or they could send it upward, away from the planets, toward deep space. They chose the unknown. From that moment forward, Voyager 1 was on a one-way journey. No course corrections, no return path. As it traveled farther, communication became weaker. Its signal shrank to a faint radio whisper. Today, that signal is weaker than the power used by a digital wristwatch, yet NASA can still hear it. Most people believe the solar system ends at the last planet, but the truth is far more complex. The sun constantly releases a stream of charged particles called the solar wind. This wind expands outward in all directions, forming a massive invisible bubble. This bubble is known as the heliosphere. The heliosphere protects our solar system from dangerous cosmic radiation drifting through the galaxy. At its outer edge lies a boundary called the heliopause. Beyond this point, the sun no longer dominates space. For decades, this boundary existed only in theory, until Voyager reached it. In 2012, Voyager 1 began sending strange data. Solar particles dropped sharply, cosmic particles from outside the solar system increased, magnetic field patterns changed direction. Scientists did not rush to announce anything. They spent months analyzing every signal, every reading, every possible explanation. Only after careful confirmation did NASA speak. Voyager 1 had crossed the heliopause. Humanity had officially entered interstellar space. There was no explosion, no visual sign, no dramatic moment, just a silent transition into the unknown. Later, Voyager detected something even more unexpected. At the boundary of the heliosphere, it encountered an extremely energetic region of plasma. Temperatures here reached tens of thousands of degrees. This does not mean fire exists in space. There are no flames, no burning wall. The heat comes from particle energy, created as the solar wind collides with the interstellar medium. Some scientists described this region as a wall of fire to explain its intensity. If a human could somehow exist there, survival would be impossible.
not because of flames, but because of radiation and extreme particle energy. This discovery changed how scientists understand the interaction between stars and the galaxy itself. Today, Voyager 1 is 24 billion kilometers away from Earth. To understand that distance, even light would need over 22 hours to reach it. For comparison, sunlight reaches Earth in just 8 minutes. Voyager exists on a scale of space humans rarely comprehend. It is far beyond planets, far beyond the sun's protective influence. Voyager's power comes from radioactive energy, slowly fading with time. To keep the spacecraft alive, NASA is carefully shutting down instruments one by one. Each decision is permanent. Once a system is turned off, it can never be turned back on. Yet, Voyager continues to send valuable data. It's teaching us how interstellar space behaves, how cosmic radiation moves, and what future interstellar missions may face. Attached to Voyager is a message, a golden record. It contains sounds of Earth, music from different cultures, greetings in dozens of languages, and images of life on our planet. It is not meant for humans. It is meant for whoever or whatever may discover it one day. Long after Earth changes, long after humanity evolves, Voyager will continue drifting through the galaxy, carrying evidence that we once existed. Voyager was built using 1970s technology. No artificial intelligence, no upgrades, no repairs. Yet it has survived radiation, freezing temperatures, and complete isolation. It reminds us that exploration is not always about speed. Sometimes it's about patience. Sometimes it's about courage. Right now, Voyager is moving through absolute darkness. No sunlight, no planets, no destination, just silence. Yet inside that silence is a signal, a quiet reminder that curiosity once pushed a small species to send a fragile machine beyond its home star. Voyager is no longer just exploring space, it is becoming part of it.